How do you transform from standard form to slope-intercept form? This is a video for task 1.6, so make sure that this goes at the top of your paper of notes, and then this video title would be on the left-hand side column. And just a reminder, slope-intercept form is y equals mx plus b. Okay, here's a reminder of what your paper should look like when you were taking notes from a video online or even from your textbook. Here's a small picture of the transformation we're going to be doing. We're going to take equations that have, we're going to take equations that have variables and numbers set equal to a constant usually. And we're going to go ahead and always isolate the variable y. So we can even box the variable y here and know that we're going to do some transformations, some inverse operations really, to get to y equals mx plus b form. Because once we get to this form, then we can easily graph. Put a little star next to it and graph. We can easily graph once we get to this form. So we're going to practice with a few examples. Okay, here is example number 1. We are going to write the equation in slope-intercept form, then graph the line described by the equation. So let's first take a look at the equation given. This is what we call to be in standard form. This is standard form of an equation. So let's write that, standard form. In standard form, we could graph by y-intercepts. So you could graph using y-intercepts. However, we haven't discussed or learned that in class. So in order for us to graph this line, we have to get it in slope-intercept form. That means that I isolate the y variable and I get everything to the right-hand side, and I can easily identify my slope and my y-intercept. Let's begin doing that now. We're going to minus 3x to both sides, minus 3x. Now I have 2y on this side because the 3x minus 3x equals 0. And this is going to equal, now for slope-intercept form, it should be y equals mx plus b form. Notice that the mx go first. This is actually going to help us identify the slope. It should go first, negative 3x, and then we add the 6 second. Remember, they're not like terms, so you can't combine them. Then we'll divide everything by 2. Since I'm going to do that on the left-hand side, I have to do everything on the right-hand side as well. The 2's reduced to 1, and then we have y equals negative 3 over 2x, right? I want it to be a fraction so I could do my slope. And then 6 divided by 2 is positive 3. So my slope is negative 3 halves, and my y-intercept is 3. And remember, I'm going to put a 1 with a circle next to the 3 because that's what we plot first. And a 2 next to the negative 3 halves because that's what we use second to count to our second point. And I'm going to enlarge the graph so I can graph on it. Still see the equation. Okay, so 3 first on the y is a y-intercept on the y-axis. So I'll make my first dot at 3. Then I'm going to go down 1, 2, 3 and over 1, 2. And that is my second dot. Now that I have 2 dots, I can create a line. Make sure that your line goes all the way through your graph and has arrows at the end. And I'm done. Let's review what we did. We took a equation in standard form and we isolated the y variable to get it in slope-intercept form. That way we can identify our slope and our slope and our y-intercept. Then we graphed the y-intercept first, counted our slope, and we connected the 2 dots to create our line for the graph. So way to go. Let's go ahead and practice a second example. Okay, for this example, you don't have to graph, but we do want to give this equation in slope-intercept form. And notice it's slightly different than the last equation we used. This one is not in standard form, but it is very close to having it in slope-intercept form. Notice all I need to do is isolate this y, and I have it in slope-intercept form. To do that, we're going to divide everything by 3, and by 3. And now I have the 3's reduced to 1. I get y equals 12 divided by 3 is 4, and 6 divided by 3 is negative 2x. Now, this is not in slope-intercept form yet, because slope-intercept form is y equals mx plus b. Notice I need to switch the 4 and the negative 2x, and then it would be in slope-intercept form. So my final equation in slope-intercept form is y equals negative 2x plus 4. The 4 is positive, so it's plus 4, and the negative belongs with the 2x, so it's minus 2x. And now I have my final equation, and it's in slope-intercept form. Notice that these are in the same formation. I challenge you to go ahead and graph y equals negative 2x plus 4 on a graph to practice your graphing. If you want me to check it, bring it to class the next day, and I can see if you're correct.